Good afternoon. I'm Mark Oden. I'm the owner of BIM Designs Incorporated. I'll talk you through a little bit about myself and BIM Designs, and then the presentation today as we all get settled. And a little bit of an overview of the presentation. We'll have each speaker will have about 12 minutes to present about their topic, and we'll guide you through what we tried to bring was a life cycle of empowering digital twins. So we'll talk about collection and capture of GIS data. We'll talk about a use case in the NFL arena, which is very apropos. We'll talk about, again, collecting data and then several live examples. So that we kind of want to give you a full idea of how to empower a digital twin through both practical use cases and the data collection aspects of it. So just a recollection of the panel topic today. It's the goal of creating BIM deliverables is to create a single source of truth for stakeholders to utilize across the entire building lifecycle. But to provide the best outcome for complex projects, managing the data, assets, and outcomes is crucial. This session will focus on the practicality of creating a digital twin from the ground up and how to maximize the ROI of the digital assets. We'll do each presenter will have about 12 minutes, as I mentioned, and then we'll have Q&A afterwards. Timing-wise, I think it'll be about an hour of presentations and about 30 minutes of Q&A. It's a 90-minute session. We do have some prepared Q&A, but I would love audience participation. Presented last year and we had great audience participation. I didn't even have to grab one of the canned questions that we had, but we do have prepared questions just in case we're on the afternoon side of coffee. All right. So just a little bit about our firm, BIM Designs Incorporated. We were originally founded in San Francisco in 2016. I acquired the company in 2018 and into 2019, and we moved the headquarters into Phoenix, Arizona, and we've quickly scaled to becoming one of the largest union-based BIM and VDC resource services companies. So we provide BIM modeling, LOD 400, detailing, laser scanning, as a service to our subcontractor and general contractor friends. We've worked on 100 plus projects all across the spectrum: commercial, residential, government, education, hospitality, healthcare, semiconductor, and we've even done sports arenas as well. So again, we offer a BIM coordination management potentially at the GC level, or we can do that on behalf of a subcontractor. We can manage coordination of the whole project. We provide the modeling service itself up to LOD 400 using union-based detailers. And for those that may not be familiar, understand the concept of union. They have 4 years or 5, sometimes even 5 years of an apprenticeship before they're considered a journeyman. So I like to equate it to they're getting their doctorate in how to build and how to construct. So these are actual construction experienced detailers that can really build to fabrication and constructability. Then we'll do 3D reality capture with laser scanning and any type of pre-construction consulting that could be cost control, schedule management, etc. So we discussed the session overview just a few minutes ago, and I'll get into introducing the panelists. So we have Ted Knaak from TopoDot, if you want to raise your hand on the way up. We have Adam Horn from HNTB Corporation. Then we have Konrad in the middle. Konrad Wenzel from Esri. Then we have Stan Hennigh from MG AECO Team D3. And at the far end we have Ray Mandli from Mandli Communications. And again, we're going to try and guide you through a journey today that helps bring practicality to the digital twin, again through data, through use cases. So to start, we'll start with Ted Knaak, and you're welcome if you would like to come to the whatever this is called. Yeah, and here's your clicker.
Right. So it's a clicker. All right, so you operate. Hello, everyone. Okay, so they gave me an extra 2 minutes, so I can kind of warm up in 12 minutes. That's pretty good. My name is Ted Knaak. I'm president of TopoDot, and today I want to get right to it. We're talking about meeting the digital twin challenge, and specifically we're taking the perspective of how do you integrate geospatial operations into these next generation design processes. So and I'm clicking, and nothing happened. All right, what am I doing wrong? Oh, didn't hit it hard enough, okay. Well, I want to start with the definition, and the digital twin is a virtual representation of real-world entities and processes, and the real sticker here is synchronized at a specified frequency and fidelity, right? Well, that's the hard part, right? How do you know what fidelity is? Basically, how much do you model? What precision? How accurate? What do you do? And how often? And what time stamp do you have on it? How often do you have to update your model? What is changing? And to give you an idea of the world we live in, we do a lot of transportation. A lot of transportation corridors. So we have things like this in this environment. How do you really, what's the digital twin is a challenge, right? How do you synchronize a digital twin on these dynamic processes? They're changing fast. How do you synchronize digital twins when individual frequency fidelity requirements vary dramatically across all the operations you're supporting? They don't all need that accuracy, and you can't afford to basically make your digital twin to the best accuracy. You'll never get finished. Is it practically even possible to develop a single digital twin to support all the operations in this dynamic environment? We would submit it's not. There's just not enough bandwidth to get it done. Things are changing too quickly. And then there's a little contrast, I'll just throw in right now. In the building environment, that process is a little more static. The building's built, it stops, you can maybe make a digital twin that you can call a model of truth. In the environment of corridors, the horizontal environment that we work in, it changes all the time. So the question is, we came up with a solution, and the solution is, and we call it TopoShare, but we're saying, you know what? If we're going to do this, we have to make it a demand-driven process, a demand-driven digital twin production process. So what is TopoShare? What does the TopoShare process really do? Well, we kind of looked at what we do. So basically, our fundamental product is TopoDot. And TopoDot is an extraction program that basically extracts digital twins from pretty much civil infrastructure and civil infrastructure, transportation corridors, rail, road, things like that. Basically heavy bridge, things like that. And what we've done is said, okay, how do we basically offer an optimized quality control process delivering all forms of digital twins where and when they're needed. We want to optimize that process, and the quality control is important. You can't just reach into a point cloud, and everybody knows here, you give 5 engineers a point cloud, they'll get 5 different measurements. And you're lucky if they're all within a foot. So you have to think about these things. So we started with saying, okay, we developed, you should create your own data warehouse. And the key here is you organize your data, your digital twins, and your metadata by project. You keep the provenance of your original project. You don't conflate all this data into one big point cloud or collection of images. You keep the original origin of everything you have. And you put that up on Amazon or Azure, and it's a 2-step process in what we do. So basically, you organize your project using an automated TopoDot tool suite. So you say, okay, you take this big data set and you make it very manageable, so you can make it a file-based approach. And then you upload your organized projects in the data warehouse. And your data warehouse is Amazon or Azure. So you do that, and it looks something like this. You basically, once you have your files, you've organized them in your TopoDot environment, your desktop environment, you drag and drop, just single file at a time, and all your files will just kind of go up and be organized up in that. So you've established your data warehouse. So what does that look like? Okay, so you've established a data warehouse, you have a geospatial operations, and he's got TopoDot, and that's his process, and he delivers digital twins. So what does that look like? Well, there's a request comes in, and that request says, okay, we need something, we need a digital twin, there's some requirement for it, right? Well, he accesses data, the administrator goes and accesses data, and he oversees a process, and he accesses data like this. He goes, okay, I gotta go out to this project, and I've got to click, that's a mobile project. When I click on that, I want to be able to find where that data is. And again, we've organized it already, so it's all file-based. It means it's very inexpensive to click, download, and bring into your local environment. And you can basically, and he can share that within his extraction team very easily. And they'll go through a quality control process to extract and deliver and give them what they need. The problem here is that there's still enormous amounts of information inside that original data that's still untapped. Nobody's touched it. And nobody knows where it is. After you get the deliverable, and it's 6 months have gone by, and Joe Engineer does not know Mr. Geospatial Administrator. He doesn't know how to get to him. He doesn't know where it is. He doesn't know what's in there, right? So what we've done is we said, okay, we've got to make the cycle. And the cycle is TopoShare Enterprise, which is a web portal. And basically it gives the access to all these supported operations to a simple URL. And then basically in that, they can see, they can have a portal into the data warehouse without touching it, without messing with that data at all, but they can extract things that give them an idea where it is, where the data is, where it's located, what digital twins are available. And the administrator has complete control over that. So he can basically go out and say, you can have access to the point cloud if I give it to you in that URL link, or you don't get that, or whatever. So the bottom line is complete control. And the other thing to keep in mind here is that, so basically we have this cycle here. Now, clear in the light blue, when you see the project data and metadata come across, the clear thing is cost. Everybody's familiar with like these point cloud viewers, and I think they're very exciting. You can kind of like go to a server, look at your point cloud, rotate it around. It's very sexy. Pennies go to dollars. When you in our approach, it costs practically nothing to look at this data and basically spread it across thousands of people because it's all file-based. You only pay for data storage and data transfer. So it's by the way, the data warehouse is yours, it's not our servers. TopoShare is just an administrator. So your digital twin, so in this concept, the supporting operations can get back to you with an email through TopoShare Enterprise and find the geospatial administrator and say, I need this, and it has to meet these requirements. This is what I need now. Can you deliver them? And basically they get unlimited access at almost no cost. It's just a URL, okay? So you can spread it across thousands, across entire operations. I'm gonna show you what it looks like in the web portal. So this is what it looks like. You just go to your Google map, and this is a single project. You could have access to hundreds of projects. And there's your web portal. And this was actually there's going to be another talk that Foth, our customer Foth, did this. This is an entire city of Perry. And the whole city administrators, everybody can see where the data is. And every one of those things, if they give them access to it, they can click on any tile they want and get a point cloud and just download it and use it in anywhere they live. So they have access to it, right? If you want to give it to them. You give them, it's up to the geospatial administrator. Then they see the point cloud, but that's a raster. It just comes them quickly. It's not 300 gig of data, it's just a raster. You can see the line work that was extracted. There's a lot of good information that, to be honest, an engineer learns in 5 minutes. He learns how to do this, and this is all he really wants, or she really wants, or a GIS person. And then basically, so we make it all interactive. You can go back and you say, we can give you this is the line work that was taken out, and we can also click somewhere and we can also bring in images and show you where they were. Now, inside of TopoDot, when you're organizing your data, you can will automatically apply the point cloud to the image. So in a file-based world, you can still measure. So you can still measure in that image now, get some basic measurements, but you're not spending a lot of money because it's still a file. You can do 15 of those images, cost a penny to download. So you're not paying dollars and dollars going through all this servers and all this gig of all this point cloud. Basically, now what can happen is there's the work order request where you can click, you can develop your own work orders, and you get back to the geospatial project administrator and say, hey, I need something here. Can you give it to me? I'm Joe Engineer, you don't know me, I don't know you, but go send me something. Here it is. This is what we're talking about. The next question is, does TopoShare, it's interactive, but does it do everything? No, it doesn't. And there's a lot of good viewers, there's a lot of good, and of course you want to go into a program, GIS programs like Esri or whatever. TopoDot extracts from point clouds. That's where our fundamental product is. But what we do is in that world, when you go to these other programs, you basically, sure, I'll publish what you need. Tell me what you need, because it's going to cost more. But if you need specifically you see something in ArcGIS, great. What do you need? We'll take it out, we'll run it through the TopoDot process, it's quality controlled, we'll sign off on it, we'll export it to Esri, you'll have it. You want to look at things in UGrid, Pointera, context capture model, the geospatial administrator has control. He takes that and he basically says, okay, I'll make you a model, here it is. They can still go get into the original data. That's, remember, maintain the original provenance of all the data. So the data is never really conflated in the data warehouse. If you're going to conflate that data into one big model, you do it and publish it where you need it, when you need it. So the entire thing is an on-demand process. It's optimized. You're not spending more money on digital twins than you need to. You're doing exactly what's needed, delivering where and when they're needed. We think that's key because in the end, a demand-driven digital twin process is going to optimize performance. By definition, it's all optimal. You're not guessing what people need. You're not guessing what downstream operations need. You don't know when you're a geospatial administrator trying to extract. You don't know what they're going to need 6 months from now, what clearance they'll need. You need requirements. So they can get back to you and ask you. It assures quality because you're going through a TopoDot process. You're not letting the whole engineering world try to make clearance measurements that somebody's going to mess up and they're going to point the finger and whatever. I know it doesn't happen, but so you're assuring the quality, you're signing off on it, and somebody has to sign off on these things. It's kind of interesting how we're bypassing the whole geospatial industry saying, no, you need a license and you have to sign off, but let's put a point cloud out there and let's measure. It's not consistent, right? And it reduces cost because you're only basically a very low cost way of getting to your data, and you're only extracting the digital twins you need, where you need, when you need them. We're working with a bunch of DOTs with this now. They're going to TopoShare to store their data, large data sets, terabytes of data organized, and it's really kind of taken off. And we have a lot of customers, and there's actually some FOT is giving some more detail on that project I mentioned about the city of Perry. So it's happening. It's working the way we expected it would, and we think it's going to move forward. And I just made the time, so that's pretty cool.
Nicely done.
Okay.
Thank you very much, sir.
You're welcome.
All right, thank you, Ted. And next we'll welcome Adam Horn from HNTB. Thanks, sir.
Great job, Ted. So I'm Adam Horn with HNTB. HNTB is a civil infrastructure, transportation infrastructure company. We're growing right now. We have about over 5,000 employees across about 60 offices. I actually lead a team in our Technology Solutions Center that is focused on BIM for infrastructure at BDC. As you would expect, my team is one of the fastest growing teams within our Chicago office. That gives you any indication about the opportunities around digital twinning. So excited to talk today about how we're approaching digital twins at HNTB. When we think of digital twins, we don't really think of a solution or a software application. We think of it more as a framework. And so that's how we'd like to communicate it. That's where we start with our clients, which our number one client is typically DOTs. So we work with most of the DOTs in the United States. So we approach it as a framework. So within that framework, this was something that we've developed to help us kind of communicate how to get started with the digital twin so that you can twin. So for us, we're looking at a current assessment of where they're at, with their data, their applications, and how we can integrate those through this digital twin framework and connect it to their physical assets. That's the goal, right? And then we're looking at, I think this is a wheel, right? So there's no starter in here. So we're saying there's no right or wrong place to start your digital twin journey. But when we apply this framework, we can be successful in looking at those right integrations at the right time, at the right phase of the project. And for us, really as a geospatial infrastructure company, transportation infrastructure company, our core data is this probably isn't a surprise. We really think we have three kind of critical data sources that we always come back to. BIM and CAD data for design, geospatial data is critical to all of our projects have a location component. And then we're getting into static and live data. That can be files, static files, or live sensor data, which I'll show an example of that at the end. So we've been applying this framework on some of our largest projects and programs like Link 21 in San Jose. I'm going to give just a couple of examples today on design projects. One of the things my team is really focused on right now is, we have a once-in-a-generation opportunity around infrastructure funding, federal infrastructure funding. I mean, we really have an opportunity right now to change the way that the civil engineering world does their work, their designs. And so one of the things we know is we have to do things differently. We cannot continue with all of the work that's coming with this investment. We have to do things different. And one of those things that we're doing is we're thinking about design modernization. And so this definitely fits into our design modernization approach. And I'll give a couple examples of that. So this is an example of a large international airport project where we're the master civil design on this project, this tunnel project. This is a federated, what we call federated model environment. So this is sort of our design digital twin. Within this environment, again, we're not focused necessarily on a tool or a software. We're just saying we have 23 design subs working across all different disciplines, doing their own processes. But we are requiring that to be done in 3D, and we're putting governance in place around the way that it's delivered. But here, we're actually taking in Esri base map data, we're taking in available existing subsurface utility information, we're taking in design tunnel from AutoCAD Civil 3D, we have Bentley in here, we also have Revit in here. We're taking all that into this one federated model environment for design. And we're already seeing value in this through Clash. Obviously, that was one of the first things, in the building industry. We're starting to see that now in the horizontal industry, where the horizontal industry is converging with the vertical industry. We're now able to put horizontal, vertical together and do those same type of clashing activities. Again, 23 design subs. So this is already providing us value. We will continue to advance the model during design through all the milestone design deliverables into construction, and then our goal is then to deliver this as a functional digital twin for operations and maintenance. This is the first 3D model that this administration has taken on. It's really exciting. It's a big project. Again, it's just another example of kind of that transformational change that we're all in right now. The last example that I have today, I really only needed like 10 minutes, I guess. This is a large complex lift span bridge, proposed bridge structure in Connecticut. Again, similar scenario of horizontal, vertical convergence. This is on a complex bridge, obviously. We also have context of the local environment. We have the waterway. But this is a pretty high level of development model, as you'll see here. And what's exciting about this is a newer tool, I guess, from Esri called GeoBem. And we saw a lot of potential in this last year. And so we said, maybe this is one way that we can handle some of this geospatial convergence. And we found that GeoBem, the application, is maybe one of the best aggregators of disparate data sets that we've seen. So high fidelity Revit model here, you can see the mechanical room here. You also have the ability to view the 3D model as it was developed in Forge Viewer. This is an example of a dynamic sensor that was actually the current temperature inside the mechanical room. And something that we wanted to see is, okay, as this thing is lifting, can we look at the temperature? Does that help us tell anything? We're trying to communicate with the bridge, right? This is a proposed model, but here now you can see this is the Autodesk Forge Viewer, showing the integration and the partnership between Esri and Autodesk. And the Forge Viewer here allows us to do some of that geospatial query that the geospatial professionals really like. We maintain the BIM data, the digital twin data in there. But now we can do that as geospatial query, identify some intelligent fire protection systems, get some documentation from that. So that's kind of a maintenance activity. And the last thing I wanted to show, I kind of teased it out, but this is an example through GeoBIM. On the existing bridge structure, there are already sensors attached to the structure that they're just simple sensors. They're just measuring tilt and temperature. But here we're connecting through another Esri service, but we're showing here that you can actually see real-time sensor data on the bridge through this application. So we can see temperature at the bottom, and then we can look at average temperature over time. And then another critical, obviously, data point for a movable bridge structure would be tilt as the thing is lifting and lowering. So you can see that on the left. We're able to see the tilt measurements at that sensor through this application. So that is an example of how we're kind of integrating to digital twin. It really does come down to a framework and an approach. The other thing I would say that is critical for successful digital twin is digital governance, because it is still somewhat of the Wild West out there. And so really strong documented digital governance around how you want things delivered that allow you to do the integrations and then use it is critical to success long term. So the last slide I have, I just always like to leave with kind of an aspirational thought or something. You know, imagine this world where we are truly connected to our infrastructure, and then, you know, how does that change how we, you know, for example, travel across the country or something like that. So that's what we're trying to do at HNTB. I really do believe that we have kind of a once in a generation opportunity to do some of this stuff. And we're really excited about kind of the future of the digital twin space. Thanks.
Thank you so much, Adam. It's really exciting to see that two practical use cases, and I'm so interested in getting to the Q&A to see some of the challenges and advice you have for the team. Next, I'd like to welcome Stan Hennigh from MG AEC Team D3.
Can you hear me? Yep. You sure can. My name is Stan Hennigh. As the slide shows, I'm the Esri Partner Manager and Senior Digital Twin Strategist for MG AEC. MG AEC is a company that's been around roughly 50 years and solving design technology problems. So when I came on board as a consultant, basically, I brought with me a background in facilities management over the years, as well as BIM implementation programs. I've worked with directly or indirectly over 500 BIM implementations in companies large and small. So, you know, just have a pretty good background in things. One of the things that I've always found that was missing, though, partly because of the friendship between two of the major technology companies, or lack of friendship, over the years, was the ability to really truly connect the geospatial data with the built environment data. So what I'm going to talk about today, I'm going to talk about a few of the projects that we've worked on over the past few years, and then I'm going to get my slides to work. And then I'm going to talk about towards the end, I'm going to talk about one of the major projects that we're doing right now that's really kind of brought all this together. I'm taking a little different approach here. These gentlemen have covered some of the things that we're doing, and that's good to see, because a commonality is finally starting to emerge in this industry. Some of the general trends, though, that we see, I want to talk about lessons learned today. Things that we've learned from various digital twin projects that we've done over the past few years on, wow, we didn't expect that, or yeah, we knew that, but we didn't know the level of complexity it might have. And so I wanted to share some of that with you. The slide that you see here now is a slide from a project that we did for Dubai Municipality about 3 years ago. It was to create a pilot for a online construction checker, permitting checker, and so forth. Really interesting project. We used rule-based technology to check the Revit models against building code standards, and then we could verify if the model was correct or not, send it back to get corrected, and so forth. The project has continued in Dubai for the past 3 years, and they've really made some excellent headway. If you get a chance, go check out the Dubai municipality site on plan submission and so forth. It's really fascinating. Some of the general trends that we've seen in digital twin now, because we work across the board with AEC, built environment as well as the infrastructure and so forth environment. We're seeing bigger campuses, bigger trends. We do work, these folks work with owners some, but it sounds like they work more on the construction side and so forth. I know HNTB works with both, but we tend to have, for whatever the reason, have tended to start working with owners, and that there's a big difference there. Some of the general trends are bigger campuses, more complex connectivity. People know that things can be connected more easily, and more complex connectivity, like a building really does need to be connected to the underground utilities correctly. Little things like that. Other trends that we're seeing are, slowly but surely, we're seeing owners starting to realize that they need or want a digital twin. Up till now, it's been, we've got a problem that we want to solve in context of the built environment we're dealing with, but we don't really know how. And that brings us to this. We don't really know how. This is a project that we did for BP. It's some scans of an offshore oil rig, and then we actually built some training programs for them, for their team to be able to switch equipment in and out and do it safely and so forth. So, but one of the things that we come across with owners quite often is, well, digital twins are cool looking, but how do we actually do what we need to do? There's 3 questions that a data guy told me a long, long time ago when I was much younger. Where does the data come from? What do you need to do with it? And where does it need to go? If you remember, I found if you remember those 3 questions, you can set up just about any project or any system-to-system connection and so forth. So we've set up a fairly intricate query process to move forward with digital twin projects as they come about. Again, usually to solve a single problem, and then kind of grows into, oh, could we do this? Could we do this? This is a project that we're currently doing for a oil and gas company in New Mexico and West Texas, Permian Basin. The other thing that so many people don't realize the importance of is location in digital twin. Now, it's not always necessary, I'll admit, but most of the time, there's a lot more tied into location than most people know. It's not just the XYZ coordinate of where something is. There's location, proximity, what, as you can see on this particular slide, what workers are near to a particular wellhead that's maybe the tank's getting full, or there's a valve leak or something like that. How do these all connect so that route planning and logistics can be handled, so forth and so on. So, you know, there's soil types, there's indoor positioning. On our stadium project, they're now doing some very interesting things with Unity, or they're wanting to do some things with Unity and the digital twin model, where they can create fan experiences using the metaverse, omniverse environment. So the imagination doesn't stop when people start seeing these things. It's really, really amazing. This is an interesting one that we came across when we started doing more and more digital twins. Now, this project is the U.S. Paralympic Olympic Museum down in Colorado Springs. They came to us and they wanted to use their Revit model as kind of a sexy tool to be able to sell this. The skin of this building has 10,000 unique panels covering it. So they wanted to be able to sell these panels and be able to allow people online to spin the Revit model around, pick their panel, and then enter their credit card number and so forth, and purchase the panel for a fundraising event. That's just one example. We've run into a lot of examples, and the main thing that we've run into is that, again, the stadium project has taught us this one. The design and construction department is pretty savvy with Revit and Civil 3D. So they're happy working in the models. The cost analysis department just needs they want to look at the model, they want to look at where the components are, but they just want a dashboard because they're not going to mess around in a Revit model. The security department that just bought 500 cameras wants to set up those cameras using the model so that they can judge where obstructions might be, where things that they have to look at are, where line of sight things are for security people, and so forth and so on. We have to create interfaces for all of those and push and pull data from the same unified model platform. What we've done is we've created a platform we call the Digital Twin Platform, or Digital Twin Foundation. And people have said, well, you can't create a digital twin with all the data for everything. No, you can't. If you can get to about 75%, you're pretty darn lucky. But what you want to be able to do is make sure that that virtual model, especially on the owner's level, is as close to the real world model and can live kind of like the real world model does. So if something's torn down and rebuilt, it's reflected properly. If data around air handling equipment or security equipment changes, that's reflected properly, and there's push-pull mechanisms to do that. One of the things that we've really concentrated on is automating this, because these push-pull mechanisms, the typical facilities management program, as well-meaning as it may be, usually falls apart in about 2 to 3 years. That's because the good intentions of keeping drawings updated, models updated, so forth and so on, fall apart very quickly because people have 1,000 other things to do. So by creating automated model checking, standard checking, programs, plus a very strict execution plan for the model, it gives us the foundation to carry this thing forward in the future. The other thing that we do is work hard to make the data as agnostic as possible, and that's kind of a troublesome term in some ways, but Revit may not be here in 10 years, or somebody else may be using something that isn't Revit, but they need that data. We need to be able to access that data through time. So that's an important factor in what we're doing. Whoops. This is our project with the stadium. Some of you may recognize the stadium. We really kind of have to keep it on the down low still. This is the New England Patriots Stadium, Patriots Place. It's a 700-acre site. We originally started out helping them geolocate underground utilities. It's blossomed into a whole management platform that they intend to use for the organization. They don't know how yet, but they intend to. As you can see from this slide alone, there's topographical lines, there's grassy areas that need to be managed, there's the stadium itself. They do about $10 to $25,000 or $20 million in renovation to the stadium each year. All that needs to be kept track of. They do retail facility leasing with, or the plan is to do that with the digital twin, parking management, forestry management. They have millions of trees, probably thousands anyway. So it's a very interesting project. It's still evolving, but I think it's the way that owners are going to go with digital twin in the future. So, just a little bit over the wire. Again, there's my name, our company. And I want to thank you and thank GeoWeek for having me.
Fantastic. Thank you so much, Dan. Appreciate the more practical use cases and the sneak peek as well. Love to welcome Konrad Wenzel from Esri.
Hey, thank you so much. It's a pleasure being here, and I'm really happy today to talk about also this topic, being this panel with these gentlemen here and learning a lot about like how digital twins and in these different industries is actually the way we work. I would like to focus a lot today about reality mapping and especially how reality capture in the fusion with GIS actually helps us to empower digital twins and ultimately the digital transformation in organizations, which is the bigger piece behind very often. Location is the ultimate integrator of unlinkable data. Everything has space and time in some sense. And that is really helping us to think beyond like specific data models, right? How can we in organizations bring data together? It connects people around their data and the important piece across different domains, enabling the digital transformation for them. And with that, it becomes a platform for collaboration across domains through exactly what a digital twin is supposed to be, like a virtual representation of the real world, including the physical objects, processes, relationships, and real-time behaviors. And as was said so nicely before, like it's a framework, it's not a technology in that sense. It's very much about the organization that reflects on what they are doing. Reality capture, on the other hand, is a catalyst, actually, for the digital twin adoption. In many, many environments, it helps us, on the one hand side, to overcome the 3D barrier. There's a big fear of many people that just say, like, hopefully I can retire before we have to go to 3D. Hopefully we can help with that, because it's a thing, right? A lot of things are in 3D, fortunately. A good thing about reality capture is it's making a lot of things intuitive to non-experts. And again, it's connecting people across domains and also to totally different environments. Let's look at a very simple example. Like you can see these 2D footprints, so very simple, like 2D vector information here, colored by different kinds of attributes in that sense. And what is really interesting, of course, we can click that. This is ArcGIS Online here, but now just see, like, with just adding like a 3D mesh fully automatically created, we take 2D content and its attributes to 3D without having to fuse the data. And that is really key, letting data rest aside of each other and just merging in real time so we don't create more dependencies between people, because that stops us in innovation. So building from existing data is also important because these are our assets, right? We have landscape models, we have building information models, we have utility information networks, we have city models. How does that all come together? And it's GIS. GIS is the framework for creating and integrating digital twins. In capturing and integrating data, in managing it, in visualizing it in real time, in doing predictive analysis or even predictive maintenance. And lastly, in building a platform for sharing and collaboration to bring people together of different kinds of domain. So ArcGIS is a foundation for digital twins in many ways since a long time already, and reality capture and data integration can help as a base, but ultimately, like, there's again different perspectives even within a single organization. Environmentally maybe, from a planning perspective, from a design, construction, operations perspective. All of these things actually can happen in the same place based on the same data that comes together. And reality mapping is this term that we use at Esri for creating accurate digital representations of the physical world automatically. It can be the foundational content captured by drones, aircraft, satellites, for example, or terrestrial sensors to get up-to-date content to create an intuitive experience in digital twins and in a GIS. We have quite some solutions there. Many of you maybe know the drone solutions. There are SiteScan and Drone2Map. SiteScan is like a cloud solution, Drone2Map a desktop solution. And on this conference here, we also announced 2 new products. The one is like an extension to ArcGIS Pro to do like full photogrammetric capability, right, in Pro, and ArcGIS Reality Studio, a standalone desktop application. So we can now in Pro directly create 3D outputs, so throw in drone and aerial images and get like content right in your ArcGIS Pro workflows and automate production with geoprocessing tools. And the other piece that we built, as you know, some of you know, like I joined Esri as my company N-Frames was acquired 2.5 years ago, and over the last 2.5 years we integrated the Shore engine as the reality engine into different kinds of these products. And Reality Studio is like taking ArcGIS Pro as a base, but we take everything out and actually build a production environment for reality capture content to support these kind of efforts at scale. It supports multi-head aerial camera systems and it's really made for advanced photogrammetry. So how does it look like? How do these results finally look like? So what you can see here, for example, is a fully automatically created 3D mesh from oblique sensors. Ultimately, there's an aircraft flying for 2 days here, or like 2 times like 5 hours, and it's going to capture you like about 50 terabytes of image data, and ultimately you fully automatically can turn these into these kind of 3D models. And with that, giving you a really accurate representation of the real world without actually having to manually create a workflow around it. Here you can see an example for San Diego. One important piece here that is really a powerful ingredient, it not only integrates geometry and texture like at high fidelity, but we also write it in a way that it can be streamed efficiently. So it gets split up into different kinds, similar to an image pyramid, like into different kinds of levels of details. And with that, you can stream it to ArcGIS Online or ArcGIS Earth, or like even into cesium clients, meanwhile, into ArcGIS Pro, and makes the data really accessible onto all kinds of clients, which is really, really important. Another example of Orlando from Elite Air camera, the Meta Duo here. And maybe showing you this example. This is like a data set captured by a blue sky. This is the original image that has been captured. This is how the 3D mesh looks like, right? So it's almost like the same fidelity. We can even use multiple images to get more fidelity, to take reflections out. And this is how the geometry below looks like. If you then like stream that on, like you can of course overlay that, for example, with a planning scenario, like in this case with ArcGIS Urban, to see how this quarter is here planned. Or look at this, like here, this is a real estate management example. So here actually 3D floor levels have been introduced. This is schematic data that is not fused into the mesh. And I really want to re-emphasize that. This is really important. This data can be updated in real time and the mesh does not have to be updated. And this is really important if you want to go to real time and to a place where many domains in the organization create the data at their time, in their update cycles, in their way. And we just bring it back together in the application that it needs, and also in the view that the particular application needs, which can be very different. Some of them need more 2D, sometimes 3D, sometimes schematic, sometimes rasters. So an example also what you can do with the JavaScript API or with ArcGIS Online, right? So here's a flood simulation for the city of Utrecht. So you can just add, like, simulate like how the water level would rise. You can even like take this on and not only from an effect point of view, but really like see how this would look like. And lastly, overlay that also like with, for example, raster information. Like you can see here to really, for example, share what buildings are affected how. Again, all this data is being rendered and fused in real time. Or this example of Sioux Falls, like from a utilities standpoint, right? If you have utilities information and you want to overlay that like in a 3D context to maybe help people to do their operations better. This is an example in ArcGIS Pro for the city of Sioux Falls with some near-map mesh data. And that's an example I really like. It's another airport example that has been presented at IMGIS last year. And actually San Francisco Airports manages all their assets in a digital twin, right? And a system of record that they stream out to different kinds of clients, like here in ArcGIS Online. You can really see they have all assets there, literally everything. They overlay that here with a contextual mesh from the outside, but they even have like indoor reality capture, like overlaid here, again, that you can stream in the internet. They have the entire BIM models up to a scale that is really impressive, as well with all the operations data. So where is actually where are what kind of people, like what is the queuing time here and there, and actually managing really exactly what we all wanted to achieve, their assets and their operations in this digital twin. Lastly, the integrations with game engines is also something that is touched on. So how does that all relate to the metaverse and these new technologies that are emerging there? Ultimately, we there have the very same goals, right? We want to have actually more people to access data in different ways for simulative aspects, for example, right here. And what is used here is the ArcGIS Maps SDK for Unreal Engine. So the very same GIS content that you have in your system of records can be streamed to Unity or to an Unreal Engine and can be visualized and be brought into different types of applications again. Because again, like, we truly have, and this was said so nicely before in many presentations, we have to adopt on what each domain needs in their data creation and what they want to achieve with the data, but also bring it back then into these different applications and make it possible to consume the data in different ways. And with that, I would like to thank very much for your attention.
Fantastic. Thank you so much, Konrad, for showing us the real-world capabilities of Esri. I got very excited there with the last slide. I'd like to see Grand Theft Auto in using ArcGIS maps. That would be, I think that's the next generation gaming platform. So thank you very much for that. All right, next up is Ray Mandli with Mandli Communications.
So I am Ray Mandli of Mandli Communications. I've been participating in these conferences for a very long time. Do anybody remember when it was called the SPAR conference? Right. Yeah, so most of you probably never went to a SPAR conference. That's what's cool about this industry. It continues to change. And we've had some really cool perspectives presented here today. So in April of 2017, I showed my first digital twin at a conference. What we did is a project for the University of Wisconsin. We took their cross-country track course and we created a digital twin so they could apply for the NCAA championships. It was the factor that got them the tournament or the final race of the year at their course. But what also happened was the other teams were able to use the simulations on treadmills so that they could practice the course, which helped a lot of strategic understanding of how they would run the course. So this is just an example of what the simulator would have looked like coming into the finish line. And this had all the terrain built into it. We also created a really accurate course. We were only about 7 feet off at the end. Originally the course was almost 300 meters off the 10,000 meter distance, and we were able to bring that all back into spec. So to kind of give us some perspective here, I don't really have to define a digital twin. We've heard that quite a few times here today. But for us as a company, it's really a digital or mathematical representation of the real world. And that's how we treat it. It's the core knowledge that we can use for compute so that we can come out with practical outcomes. What we do for visualization, though, is we use digital terrain models. That's the part where we display what we've come up with. And we feel there's a distinction between those two, especially when you're doing things such as simulation. In simulation, you shouldn't have to look at a simulation. Simulations should be able to run on their own, and that's where you use the digital twin without any kind of visualization with it. But a simulation allows you to put different influences on the data and see how the outcomes change. And this is being used a lot in the autonomous vehicle industry. We're working with multiple facilities that are using simulation right now. Now, how do we get there? How do we get this data looking decent? We use something called conflation. So let me talk a little bit about conflation. We've seen it here. Everybody here at on the stage has used conflation. We just give it a word that helps us describe it. It's the process of combining overlapping spatial data sets to produce a better data set with higher accuracy. Let me show you an example of this. This is the Ala Moana road that's in Hawaii. It's just before you get to Waikiki Beach. And we use this as an example. We took some airborne LiDAR. We added our terrestrial LiDAR, and that helped us define it even better. But we had another little trick. We also do pavement data with a very high resolution scanner, and we're able to drive down each lane and put that together as a mosaic. We get 1 millimeter accuracy with that technology, and it really tightens this up. This led to a project that produced over 400 3D intersections for their connected vehicle corridor. Currently, we collect with the big vehicle, we run down the road. There's a lot of latency, sometimes up to 6 months delay. It costs over $200 a mile. In the future, we're going to see all this data coming from things like ADS vehicles. It'll be brought into a dynamic mapping center, and the price will go down to $5, maybe even down to $2. What we produce out of that is ad maps, DTMs, digital twins, imagery, data, DOT data, but we collect it with the big vehicle. We can also use other sources, like delivery vehicles, maintenance vehicles out on the road, and from personal devices. So here's another project we did. This was kind of a fun project for us. The Fitchburg Fire Department, which has an EMS team, they were having some issues with a mountain bike course that had been built in the community. And so this is a map of the mountain bike course called Quarry Ridge. And what the problem was is people fall off their bikes and get hurt. And it's very difficult to get access to where they are. So they wanted us to come up with a map. And we said, hey, why don't we try something really cool? So instead of carrying the payload ourselves, we actually had the firemen carry the payload. This is using our Maverick portable system. And they went up into the area. We took the Maverick data, we ran it through a process we call distillery, and we split it into 3 different threads. One thread was for feature extraction, rescue markers and trails to define that, and then we did a feature export shapefile. Going in the other direction, you come down the middle and there's the imagery. And then we also did another, we managed the LiDAR data, converting it to LAS format, and we filtered it, we merged it, we created a terrain mesh and terrain raster. So the output from that is the terrain model, and then it could run in a piece of software that we have called Roadview Explorer. So this is the LiDAR data over the area, and then we extracted out the GPS information for the trails and put it into aerial imagery, put that together, and we created this beautiful digital terrain model of the area. From that, we added the intelligence to that, and we also had the viewers so they could visualize this. So this was for training, and when they're coming up on the scene, they could tap into this software. It has the imagery, it has information about location with the map up in the upper right, and then the LiDAR data down in the lower right. And as you can see, this is all part of a viewer platform. And it's really helpful. Actually, the firemen did fall down while they were carrying the payload, and we do have that in the video if you look at it real closely. So this is the output. So we had the whole area, we had it mapped out, and if somebody's cell phone, the Apple iPhones now tell if you fall, your Apple Watch will tell if you fall, it would put out a signal, and the fire department would know how to bring in the crew. And you can't take any trucks into this site, so they'd have to take up a backboard and carry the individual out. If you want to look at that video, if you have your phone or something, you can take a picture of this website. This is a live website that they're using today for this information. So what else do we do with the digital twins? One of the areas that we've become experts in is the HD map, and we have a version we also call XD maps. So what we're doing here is we're finding information in the infrastructure, such as signs. We can do location and type, but we also give the RFA value. That's the retroreflectivity of the surface of the signs. We can do the same thing with pavement markings, and we can do that for both wet and dry pavement. There was a national mandate put on state DOTs to actually keep track of their pavement strips, and it's generating a lot of work for us at this point in time. So roadway surface, we do have the ability to determine the type of the surface, the coefficient of friction. We can use GPR to look what's underneath the surface and create an international road roughness index. We look at barriers by type, free space. Free space is really important for autonomous vehicles because you don't need to know everything. If there's free space there, you just define it as free space and you don't have to continue to reproduce it. But we create vectorization to define free space. In Hawaii, we did 440 signalized intersections for their connected vehicle corridor. We're doing ADS for rural America for the University of Iowa, which is a really cool project that was funded by Federal Highways. And I'll show a picture of that here in a little bit. Drive Ohio, which is the ADS project in Ohio. We're working with both the test center and the state. And we got various other projects that we've been using the digital twin technology for. So here's a little video on HD maps. And this is the autonomous footprint for HD maps. So first of all, HD maps are implemented for 3D representations of things not found in traditional maps, such as traffic signs, barriers, lane markings, and other maps have to be unbelievably accurate. And in our work with them, what we find is that even though the infrastructure doesn't change, the way you want to use that data changes. So we have to redo those maps. So here's an example. This is in the city of Peoria. This was done for autonomous stuff, a company that's now owned by Hexagon. And this is their test bed for testing their autonomous vehicle mules that they build for universities and test centers. And you can see the visualization here is real nice. But the data that's really important is all the decision data. You know, we have to look for the observable objects. You come up into an intersection. You know, intersections are very complex. You have to be able to understand all the lanes. You have to have all the rules written into the map. So that's the data that goes into the map. And we provide that through, we do AutoWare and also do OpenDrive HD maps. We also do Karma maps, and we produce the SAE standard for maps also. So all the lanes and everything have to be considered in this process. Again, this all starts out with the exact same digital twin that we use for everything else we do. We don't change the vehicle. We go out, we collect this data, and we just use it, and we add other pieces to it in order to get the accuracy. Here's the Iowa project, the ADS for rural America. It's over 40 miles outside of Iowa City, and they have, it's a rural initiative to allow people who live in those rural areas to be able to come in. It's operating through all 4 seasons. You know, we're looking at have all the safety factors involved. There's a lot of different aspects to the project. This is the visualization of the HD map here. And we've built these for Willow Run, the test track in Michigan. That's University of Michigan is operating there. There's a lot of autonomous vehicle projects. Transportation Research Center in Ohio. This used to be Honda's, the former Honda testing facility, but it's now run by an independent nonprofit. And along with that, we're also studying ways to collect the data. You can't collect everything with LiDAR. You can't collect all of it with imagery. Sometimes you have to meld other technologies together. And we're working on some systems here that are actually being looked at by the OEMs or the car manufacturers. In this case, we're looking for reliability of the lane keep system and being able to see the data that's on the road. So this information is real time, using the digital twin, doing comparisons in real time with the digital twin to solve the problem. But you know, sometimes the stripes just don't show up. You know, the sun is at a certain angle. You get reflection off of other cars. Again, here you can see on the far left, at nighttime driving, and the stripes are hard to see, but with the different sensing technologies, we can get higher levels of you know, certainty that we see them. And the fog is one of my favorites. You see driving in the fog there, it really drops down. But with certain camera technologies, we can see through the fog. And that's my presentation. Now we're going to questions.
Yeah, fantastic. Thank you so much, Ray. I love the tie-in to autonomous vehicles. I just noticed in San Francisco, a fully autonomous vehicle taking passengers from point A to point B. So it's here. So thank you for all your hard work there. I am extremely honored and proud to be on stage with these gentlemen that have accomplished so much, and I'm sure a lot of what they've shown is it has not been that easy to show up. We're only about 10 minutes away from here and happy hour at the exhibit hall, but I love seeing that we saw the intersection of all key topics of GeoWeek presented on stage here to show the practicality of creating that digital twin. So we'd love some audience participation. We have a limitation in microphones, so Jeremiah's offered to grab one of them. Perfect. And if anybody has any questions, feel free to raise your hand. I think we did an amazing job covering the practicality of digital twin. I observed, in years prior, it was very theoretical. It was all defining what is the digital twin, is it going to happen, can we get there? And what I'm seeing in just the last year alone is we're there. we're absolutely there. So I'd like to, in the Q&A, in about the 10 minutes that we have for Q&A, of course, open it up to the audience, but also to focus on the ROI side. Feel free to interrupt me if you like. Otherwise, I'd love to chat about with the team, how are we, after these probably very expensive mega projects, how are we showing the ROI back to our clients? It's an open-ended question. Ted, if you'd like.
Okay, but I didn't.
Okay, well, just from our perspective, kind of reiterate what we were looking at is that I think you have to look at a digital twin really, you have to look at it from an economic sense. There's labor input, there's time input, and they cost money. So the question, so what we're trying to say is, okay, in our perspective is, and everybody else's has to, you have to get the requirements, what do people need, what are they trying to accomplish. It gets difficult to implement when you have very complex projects and you have so many different downstream operations trying to accomplish different things. So the question is, so to optimize and maximize the ROI is to specify what you need to establish that collaboration so they can say, this is what I need. I may not need too much from it, I may need something. This is worth money to me, and this is what I need from it, and then talk to the right people who can extract and get what they want. So I think that was our on-demand side of it. And there's been amazing projects here, but we kind of, we're looking at a fundamental approach from data to, okay, how do I give people what they want when they need it?
Fantastic, thank you, Ted. Yes, sir, Ray?
So in our world, we try to collect once and use it over and over again. I have data going back to the beginning of LiDAR. We did our first LiDAR project in 2008. I still have all that data. We have it stored, and we've gone back and used it. It is all labeled, so now a lot of it can be used to create AI because we have labeled data to do comparisons against. So it's the reuse of it. We are working with a lot of different entities who will come up with an idea as to how they want to use the data, and then we show them what the capabilities are. And you can see the vast array of different ways you can use it, and they go, oh wow, I'd like that. Well, one of the hardest things to do is go back and get that data. So if you have that in the can, I think we're remining data for the state of Illinois. We're doing assets, and Kentucky has assets that we're going to go back to their data and pull out. And they're sometimes assets they never thought about when they started the project. But the other side of that is take as much time as you possibly can at the beginning of the project to plan, to try to figure it out, to demonstrate, and do all the things that make people think about what they can do with that data.
And Mark, if I could,
Go ahead, Stan.
There's 3 quick examples that I can give you. One is on the oil field project, it was regulatory. And if they don't meet those regulatory restrictions, it's very expensive. So to do this work and save the time virtually has saved a great deal of money. On the stadium project, we originally started with their design and construction department. And their design and construction department, when they, as I said, they do 10 to 25 million in renovation a year on the stadium, not to mention major projects. They haven't been able to find anything. They've been able to save as much as 60% on the project startup costs because of an accurate digital twin now. The most interesting one though is, they say, is saving money making money? Well, different organizations answer that in different ways. The interesting one with the stadium project though is, boy, once they got a hold of the idea that they could create fan experience that fans were willing to pay for, everything from knowing where beer vendors were that weren't as busy as others, to taking virtual skydiving and being able to land in the middle of Gillette Stadium on the 50-yard line and charge $50 to do that. So there's a lot of ROI possibilities here that people just don't think of, and it's going to get fun.
Thank you so much, Stan. Did we have a question from the audience?
I want to leave it open to anybody, if anybody has one, but if not, what I wanted to ask was just about how the expectations of digital twins have changed. I imagine the conversations that you guys have had. I mean, digital twins have been around for years now, but it sounds like the conversations you're able to have this year are different than a few years ago. So could you talk about kind of the evolution of these conversations with clients and potential clients?
Steal the show here, I don't really do that, but I think that one of the biggest areas is that, as I said early on, we've been called in to solve a problem in context of the environment, the virtual environment. That's been kind of the impetus to get digital twin projects. Now what we're seeing, we're in conversation with a couple major transportation facilities that are saying, no, we need a digital twin so that we can solve problems in the future. That's an interesting shift.
I think for us too, we sort of used to have to try to sell this idea of 3D design, at least on the horizontal side. And now it's quickly turned into, we take an approach, what we call model first. So that's how we sort of present the idea of it. And we say, oh, if you just take this model first approach, we just do it in 3D, now we're going to get all kinds of downstream opportunity to do things like simulation analysis, other integrations. Now it's almost the technology is there, the capabilities are there in the industry, the talent is there, there's just almost like a demand for it now. We don't even really have to sell, there's just like an expectation that you're going to do this as a 3D model. And that's just kind of understood. I think the other thing that we're seeing on the DOT side is that we're facing, that industry is facing a serious human resource issue, like major turnover and not replacing at the rate of turnover. And so I think they're really thinking about like organizational, operational change management and how do we upskill new people in that space and try to save the knowledge that's leaving and then pass that down. And the model always, I mean, for the younger generation, that's a very easy thing to transfer to them. They get it, they understand it. Again, there's almost like an expectation that, well, yeah, of course I have a 3D model. But that hasn't always been the case. I mean, it's a very new thing. So I think that's what we're seeing. And then on the ROI, just to touch on that, I think like value-based or financial-based ROI is still maybe a little early. But what we're seeing is just additional things like, we're doing things now like real-time simulations, things like that. VR, XR, all that stuff, because we have these really high-fidelity 3D environments. But we're doing things now that we've never done before, like training. You know, there's like, oh, now that I have this thing, can you show us what training would look like for a volunteer team to go out to this site during a natural disaster and then build this virtual training experience. So it's like opening up new services for us too.
I think the pandemic forced us to, since we're no longer collaborating in the same space, the digital twin has filled that void, and there's some incredible software. We saw some of it here today. That Esri software, I already got 3 ideas that I want to use that for. It's amazing when you see what we can do with it. But because we're not, I work with DOTs, and there's DOTs that I got to make an appointment like 4 months in advance to get everybody in the same room. So here now I can just put it all up in Teams or do a presentation, and then they can follow through. We just did that with RTC of Southern Nevada. And I think 45 people, the presentation was 2 weeks ago, 45 people are using that technology right now.
Maybe to add also like something on that, I think one thing that we often saw is, especially after the early adopter phase, people need to see and to touch it, right? It's really important to get it in many people's hands and to have them interact beyond that. One thing that many people thought is like 3D visualization is just a visualization, right? To be really being able to focus on answering about business problems. That has been a thing, and like we realized that reality capture is also helping a bit in that. Like Jack always told me like, Konrad, you know, we're showing 3D GIS demos since like 20 years, and now we just add a mesh to it and everyone is like, boom, wow, what's that? like it's yeah, and he's right, you know, like it's interesting, like a lot of things come together, but so there's a few technology components like being able to stream, but then also what it ultimately comes up to is making it accessible to people, making it easy to get to it, like in a web browser, really getting to data simple, and especially then giving people a way to get started in an easy way, and starting small and giving an evolution instead of this massive digital twin project and we build one data model to solve it all, which is actually not possible and not what really happens.
Yeah, well, I couldn't agree more. So it's just like I could give you a million anecdotal stories about, just customers we've had that the geospatial department took data, and 6 months ago they delivered a project. The engineers 6 months, a year later need something. They go out and survey it again. They didn't go across the hall and talk. We talked about even with so the communication, establishing that communication, and as Konrad is saying, you want to establish communication. You just have to establish what's the right word? Communication and awareness of that. This can be done. It's here. Let's go look at it, and it has to be done inexpensively. It's a little difficult to go. Here's some of the practical side that you have small business owners, geospatial guys out here that you have business. You can have this massive point cloud that you said it has all this information in it, but it's very difficult to go around to every department in the DOT and market it, because it just keeps showing up and saying, hey, I got this stuff. If you ever need, guardrail heights, call me. Well, guess what? By the time you get there and somebody wants guardrail heights, you're not making any money and you're just like bleeding cash, just going around talking to all these people. Again, it's about the awareness, about the thing that they can get to it. They have a simple way of doing it and saying, okay, well, I see your picture, I see what you have. Can you get me guardrail heights? And the answer comes back to, okay, well, from here to here? Yeah, and that's going to be about in 4 hours of my time. What do you say? $300? Okay, fine, good, we're all good. Everybody's happy. But no one's going to do a digital project, a digital twin for $300. But those people can use it. And it can be used collectively over and over again if you establish that communication. So that's kind of something to think about. It's very hard to market that you have all this information-rich stuff. It's very expensive, and that's another thing that kind of slows things up. It's to use that data again and again. So something to think about.
Lovely, thank you, Ted. So, yes, sir.
Oh, sorry. What's coming there?
Hello. My name is Tony. My name
It's like a candle. It's like a candle when you blow out. All right. Feel free to speak up, yeah?
I came from AI startup company, so very different field. I analyze satellite imagery data with AI technology, but so I'm not expert in BIM or AEC area, but what I see the similarity between the AI and the digital twin is they're very expensive and they're very time consuming, and you mentioned training, but the difference is, I think, is in the AI field, when you are not able to deliver the results, the customers still understand, but you guys are not, because you guys are doing the projects that is going on, or whether it will be going on. So in the AI field, we're still struggling, but you guys are actually delivering the results. So I'm curious, on top of your mind, what are the most satisfying customers' feedback when you deliver the digital twin result to your customers? So like, whether their efficiency, they actually can visualize, or what is the essence that customer really kind of open their eyes and see the value of the digital twins?
Well, I'll just keep it short because I think everybody has something to say about that. First of all, it's better, faster, cheaper, really. I mean, mobile LiDAR across some transportation corridors, they're taking 8-month projects and delivering in a month or a month and a half, so that's right up front, you've got something, right? And then you have all that data that's available. Anecdotally, it's interesting that we hear from it through our customers, and we've been told that they've actually eaten up engineering budgets with busy work because the engineers got done so fast. They had so much data. They had so much more data than they usually had. They got it so much faster. And having the digital twin, the very representative and detailed digital twin, that the engineers, the managers confided in us that I just had to keep them busy for 3 weeks and spend money to get through the budget. It was just like they were done. So there's this efficiency that people are seeing, now, and it's happening more and more. I don't want to take too much time.
I was there at the beginning of LiDAR. I have an HDL 64 original, one of the first 20. It's a boat anchor, but we keep it just to remember where we came from. I used to think just showing people LiDAR was like the biggest thing in the world. And then I found out, well, that wears off after a period of time. Actually, what's really getting a lot of attention right now is when we use AI to take multiple LiDAR sets and we take multiple cycles and pull data out and see what the change is. And then to be able to have decision-making processes down the line. So, we all heard about ChatGPT and how big a deal it is. It's only scratching the surface. There are so many amazing ways that we can eliminate the time and the labor it takes to do these processes where we're moving files over in Excel and stuff like that, where we can automate these processes. That's really the place that yanks my chain now. And I can tell you, everybody I show that to, off the charts. It's one of the biggest things that's happening with this technology.
I think mine's a little simpler, but it kind of shows the human side of things, people getting their jobs done. And we had a construction manager at the Patriots organization, and we kept telling him, you need standards, you need to do this properly, you need to set the model up properly, and he just kept fighting us. And by hook and by crook, we got it done anyway. And he was looking for some, actually ceiling fan components of all things. And he got in the model and found his ceiling fans, pulled up the manuals, pulled up the part numbers right there in context. And right there on the Zoom meeting, he goes, "This is so effing cool." And he didn't just use effing. And he said, "I see what you were talking about now. What used to take me 3-4 hours to find all this data, I just found in 30 seconds. And that's really satisfying when people get, because that's what we're all about anyway, is getting jobs done better, getting stuff done better.
I think we have time for one last question.
Thank you. I just like what I see, but I guess this is a question for the moving forward, and it's related to what Konrad was saying from a user point of view. So it would be nice, right? I saw different things like the TopoDot use their software to extract. I see that 3D stuff, I see that. I wonder if in the future, we as a users are gonna be a not unique or solve the problem kind of engine that I can say, oh, I got this engine, then I can bring the different things instead of, we do a lot of Esri stuff, for example. So do you guys see that in the future? Is gonna come something like that, one engine that would move most of that stuff? As I said, I like what I see here. But from the perspective of a user, how can you move forward on this?
I think, I guess time will tell, right? Ultimately, but I see this as an enabling technology, and I think we set it up, and I think the future, what we are trying to paint is a future where you are connected to your, if you're an owner, you're connected to your assets, the things that you own. And you're connected in a way where your assets are telling you, or they're able to start to predict issues, right? So it's not just about, I have to go in, maintain some maintenance log manually, and then I have to go check it and say, oh, this thing needs, this piece of equipment is due for maintenance. what we want to get to is where this information is connected, the data is connected, you're connected to it in a way where it comes in and alerts you and says, hey, I have an issue. And you start to have a conversation with your infrastructure. And it's telling you if it's healthy or if it's sick, and you're able to respond. Maybe it fixes itself, or it tells you what it needs and orders the parts and is able to sort of facilitate fixing itself. I mean, that's kind of where I think we're trying to get to, and I hope some of that came across, but that's kind of the future that we're painting for infrastructure.
I think. Were you asking about a single platform, or was it all going to come to a single platform, or in your question?
Like a brain, like an artificial brain.
Would be better a single platform.
Oh, yeah, it would be better, but no, sorry. No, actually, here, I mean, look, different softwares have different capabilities, really. We developed ours on the Mandli platform. It's really good with point clouds and CAD. CAD is different than GIS, and they're set up differently. They do different things, and so you'll always be part of the value added of HNTB, whatever. You take all these things and you basically. That's the service provider, that's the systems engineer job to make it all work, It's very focused. We do very focused things that nobody else did, and as a small company, we've grown and been successful because nobody else focused in our niche, and been successful there. So other companies are doing other niches. You'll be doing with a couple of different platforms for a while. And if I could just summarize everything, I think one of the big ROIs is really reducing uncertainty in your whole process, in your building, construction. The more you know about the process, digital twins give you knowledge. The more you know about it, the return on investment is really, really huge. And that's kind of the big picture.
One last point I want to make is the only constant is change. And looking across this room, there's many of you, I've been in this for a long time, there's many of you I see I've never seen before, and that's what's cool about it. It's drawing in all these people. At the same time, today was the first day that we didn't have Velodyne as a company. As of this morning, Velodyne was shut down. They were the people who brought LiDAR to this industry, and that's the change that we have to be aware of, is now we need to continue to step up and build the next thing and make it better. So change is constant. We all have to adjust with change.
And we can honor those that came before us. Thank you so much. I want to thank, and to create some energy right before happy hour, I'd like to applaud everybody. Thank you to Ted, to Adam, Konrad, Stan, and Ray. Thank you all so much. Appreciate it. Thank you to the audience for being great participants, and let's enjoy ourselves this evening. Thank you all.